Hi everyone. My name is Sue Bays and I work as a Power BI developer. And I set up my own business a few years ago and have been fortunate enough to be employed full time ever since. I guess I must be doing something right. But what I wanted to share with you was some of the key structures that we need within Power BI or within any data analytical tool to be able to structure and present our data. If you have any questions, please feel free to ask them, to chat away in the meeting chat. If I don't notice them, then Kendra will ask you as well. But I always love hearing from people that are there, and any questions, please just throw them in and it makes it much more enjoyable for me. So without any further ado, this is me. I use Power BI, Excel, or Python, and I can program. And if you want to reach out to me, I'm quite active on LinkedIn and very active on Twitter. So any questions, anything you want to contact, then please do. And I tend to share things that I find of interest. So that's usually quite nice. So at the end of today's session, what I'm hoping you'll be able to achieve is to recognize basic concepts behind different types of data. You'll also be able to understand the importance of data types, so they are different things, how to model data within Power BI and in Excel, to understand what we mean by normalized data, why you've probably heard of a star schema and why it's important within Power BI, a little bit about how the engine behind Power BI works, and really that's basically what we're going to be covering for the next hour. Any questions so far? Don't see any. So when we start looking at different types of data, then generally they fall into three different categories: those of numeric, categorical, and time series. So our numeric data is data that is quantitative, and it's something that actually is measured. It enables us to add it up, divide it, compare it to other figures, and it basically is either discrete or continuous. So what do we mean by discrete and continuous? Anyone want to make any thoughts within the chat to pop in what we mean by discrete or continuous? Then write it down for me. And there are questions coming later with some graphs for you to interact. So discrete basically is something that we can add up and it's a fixed value. So cash, money, would be a discrete amount you either have in the UK, £5, or in the US, $5 or $10. It's a fixed amount that you can actually add up. Whereas continuous generally falls upon a range. So a range could be something like your age. I'm 53, but I'm so many months, so many days, so many hours, so many seconds, milliseconds, and it can go on and on and on. So this is what we mean by continuous. So we have discrete and we have continuous. We then move into our categorical data, and our categorical data is what we tend to use sometimes for our dimension tables. So these are things like, if you think of your table, it could be a gender. So which gender does somebody fit into? What's their marital status? And these are things that we're allowed to group these actual quantitative numbers into different groups. What's somebody's hometown? What type of movies? And I always think of continuous sounds like there are no gaps. Yes, absolutely, Kendra. Thank you. I do like it when people talk to me. I feel a lot less alone. So our categorical, I always think of as like our storytelling. They tell us things about something. So if I was to say to you, I had £5,000, you might say, well, is that good? Is that bad? But if I was to say, well, I had £5,000 this month, compared to £10,000 last month, then you are actually able to compare and you can see if there's a story. So you can see if things go up, things go down, and it gives you more information. So I always like our dimensions and think of them something that gives me stories and information about the tables or the facts that we're looking at. So our categories tend to be qualitative data, and it actually gives us much more of some quality information about it. In the same way that we had discrete and we had continuous data, when you actually look at our categorical data, we can differentiate in two ways. So we have nominal data, something like a hair colour, which actually has absolutely no order whatsoever. It doesn't matter whether you put blonde, brown, black, red, in whichever order, they have no fixed order. Whereas something like ordinal data, perhaps a job hierarchy, that does have an order. And when you start to manipulate and to visualize data, the order of your categorical data, when it has ordinal data, actually has a significance. And that's what you need to build into your model, an ability to be able to sort. So can anyone think of something that is we use all the time within visualization that has ordinal data? So we have to specify how we order it. We can't go by its name. Date, absolutely, George, date. When you first start months, brilliant, Cornelia. Yeah, absolutely. Your date objects, when you put them in, the first time you put it in, it's April for April. And, obviously, if you've got a financial calendar, that's great, but that doesn't mean that May follows. So date objects like calendar, we have to build in an order into our dimension table to allow us to sort it and filter it. Nice to hear from you. Oh, Johnny's there. Hi, Johnny. So when we start looking at our graphs here, so here are a couple of graphs. What type of data? I know on our axes we have, it shows us a picture, but what type of data is the number of customers? Would we say that's discrete or is it continuous? Just have a sip of my tea while you write in the chat. So going up the axes, number of customers, discrete or continuous? Brilliant, brilliant. Discrete, yeah, because the number of customers that we have is definitive, whereas our continuous going along the bottom x-axis, that is going to be continuous. So we have customers, discrete, going at the y-axis, y to the sky, whereas going along the y-axis, that's our continuous range. So again, if we look here, we have our revenue by category. So our revenue going up the y-axis, y to the sky, that's going to be discrete. And going along the bottom on our x-axis, we're going to have what type of data? Categories, brilliant, thank you. Categories going along. And you can see how this gives us much more information about our table, our graph. It tells us, we can look at it and we can see that media is actually selling more than office supplies. So that helps us make decisions. And then we have another one where we start looking at percentages. Now, there is mixed views on percentages, but what do we think? Do we think it's going to be discrete or continuous? There's whole Twitter feeds about these. Personally, I would put them as continuous, although Kendra, like you said, yeah, definitely, Cornelia, can be both. If you've got something that's 100%, it's 100%. But if you've got something that's 33.33333, then it will be continuous. But by understanding what type of data that you have, that enables you to draw the visuals that you need for your visuals. And we can then start to build some really nice visuals, but the data has to be in the correct time. The other area that we look at is we look at time series. So we've talked about categorical data. I want to versus 1% growth matter. I think so, Gina. It depends again, you know, looking at the visual, what visual you would be looking at. Yeah. I'll go on, but then I can chat about that in a little bit. So time series, when we start looking at time series, time we generally have on our x-axis at the bottom, and we're able to use that to actually see how are we performing over time. But then we can also use it to forecast forward. And so that's another key way that we can actually have different types of data to give us more insights. And within financial modelling, all the time we're looking at performance, forecast, comparison. How are we doing compared to last year, this year, last month, different seasons. So again, we have our time along the bottom, and then over the top, we'll have our different visuals. So enabling us to compare sales amount and budget by different dates.
Sue, we have a question from Gina. She asks, would whether you're measuring percentage as 1 to 100 versus percent growth matter?
As into which type?
Yes, I think that's what Gina meant. Gina, correct me if I'm wrong. In terms of categorical versus discrete, she continued.
Okay. So continuous versus discrete. 1 to 100. Yeah, it seems like, I guess if you're rounding it up, then you would have a more definitive, in terms of formatting, you would have a more definitive discrete amount. But yeah, percentage growth could be anything, because it could vary, and it could be over 100%. It could be much less. So yeah, I think I would be probably looking to see what the data's showing me, and then using that to decide how to visualize it. Hope that helps. But I've got this, I'll share a couple of links. There's lots of interesting conversations about it. So when you start visualizing your data, I don't know if any of you use Excel or pivot charts at all, but this is where we start to really drill down and understand how, when you move from an Excel background into visualization, how by understanding the types of data that you have within your reports is really important to how you visualize it and how you prepare it. So we have, in the values, we have our measures, or we can now have implicit measures within Excel. So these are our numbers, these are our measurements, goes into the values. Whereas within our filter pane, our columns and our rows, we have our categorical data, so that we're able to understand and see what is happening within each area of our chart or our growth. And it's useful to know what type of data you have and what it does to enable you to actually structure your chart and where you put it. So sometimes if you put them in the wrong fields, if you try, you can't actually put your values in your filters. So from a business context, I find it useful just to sort of group and understand, when I look at data, what it's telling me and what it's showing me, which then helps me model and create my reports. So the other thing to consider when you're looking at data is, where is the data coming from and how is it structured? So structured data is what probably a lot of us are dealing with, very much like things from CRM systems, from databases, where we have different credit card numbers, we could have customer names. It's very much structured. We're able to clean it, we're able to model it, whereas your unstructured data could be absolutely anything. It could be audio files, it could be emails, it can be anything from word processing or text. And this is the difference when you start looking at data, is understanding what you've actually got and how you're going to be able to manage it. So roughly, what percentage of data do you think is unstructured? Anyone going to go for a guess on a Friday? Yeah, Cornelia, 95%. Yeah, a lot. So when I carried out the research for this, I think Garner said it was about 80–90%, but I would say now that we're probably up to about the 95%. Majority of data that is stored, this is a couple of years ago now, was 80% from Gartner, but it's continuously growing. So most of the data that is created is unstructured. And this is where you would use things like, you can use different types of data modeling systems that are specifically used for this. For example, Python and R are great for dealing with unstructured data. Our structured data is basically, it can be displayed in rows and columns. It's lots of relational databases. We have numbers and strings. It requires less storage and it's easier to manage. Whereas our unstructured data can't necessarily be displayed in rows and columns. It can be just, some of the stuff that I work on is sentiment analysis of just plain text, where you have to pull it in, create a structure, and then understand, some of the meanings and the feelings that are evoked from different words. So with that, you have to use possibly different types of software depending on the size and the quantity. What we're focusing on today is probably more structured data. So when we look at structured data, I like to think of it as tidy. When you move from Excel to Power BI or R or Python, what we're primarily aiming for is a really nice, tidy data set. And I'll explain what I mean by that shortly. So you would look at this and you would think, actually, is this a nice, it's structured. We can see we've got the months going along the top. We've got our categories of what we're spending money on the bottom, and we've got a nice summary. But if we wanted to compare 1 month to the next month, we can do it within here because we've only got 3 months. But if you've got lots of data and lots of columns, then it becomes more difficult. And what we're looking for, the key model that we're looking for, is something, again, this is another example of structured but not tidy. It looks tidy, but we've got all the months along the top, we've got our categories here, and we've got our values there. This is what we're looking for. This is the holy grail of data. So within that, it's called tidy, and this is coined for me from R when we start looking at tidy data sets. Each column is a specific thing. Just have a sip of my water. So along here in our first column, we've got all of the dates. So it's one single thing, one variable. Our next column is our account type. And again, one single thing, it's an account. And our department here, one single thing. So, and then our observation is a single value. So if we look here, we can see this on this date, this account, this department had a sum of money coming out of £26.03. We haven't got any commas there saying it was £13, £15. It was actually one amount. So each column has a variable and each row has a single observation in it, and each cell has one single value. And this is what we're actually aiming for when we start looking at any unstructured data or any data coming from any source, is that you get to this particular tidy data set. So when we looked at our previous order, where it wasn't tidy, this is tidy. So we've got our order number, we've got our order date, we have our index, we've got our channel. And what this allows us to do is it allows us to actually filter and to group and to aggregate. And this is what we're looking to do for all of the data that we bring in. If you're lucky enough to deal with and have a database, a data department, and they manage to get all of the data into a database for you, this is rather nice. For me, as a external consultant that works, most of my businesses are fairly smallish in that they don't have a data team, a data department. So a lot of the data that I get is very, very messy. It's not necessarily in this format. And you need to learn the skills to transform the data that you pull in to make it go into this format. So the date is unpivoted, whereas when we go here, the date's pivoted. Dates unpivoted. So once we start having our data into separate columns like that, whilst it enables us to filter and it enables us to group and it enables us to aggregate, what it also does is it allows us to define each column by a specific data type. So within this, we look at our expense items. Our expense items are text, our expense categories text, our month is date, and our value is a decimal number. Now, why is this important? So basically, if you want to create something like this, knowing and setting the structure of your data up into this beautiful table with the set categories for each different data type enables you to create visuals such as this, where you can actually filter. So when I say I'm filtering, I can filter by the year, I can filter by a category, I can filter by a month, and I can group. And this is what having a tidy data set allows you to achieve. So when we're looking at these, any questions so far or good? All good? So within each column of each variable, which is independent, because this is a date, it's an object, and that object allows us to do certain things to it. So because it's a date, we can find the minimum, we can find the maximum, we can find the days between, we can pull out which month, we can pull out which year, and it allows us to do certain things. We can't necessarily do that to text, because text will allow us to do an uppercase, a lowercase. It might enable us to count the characters. We can put it, we can find ease, we can look for certain things that we can do in a text that we can't do to a date. And the same with our categories, our payment type, we can do certain elements to our text categories. And with our numbers, our units, we can do adding, we can sum up, we can divide, we can round, we can times, we can take things away from each other. But you can only do you have to format the different data types to be the same data type if you want to do things with them together. So just out of curiosity, how many of you have used Power BI so far? Just going to pull over my practice model to show you. Yeah, love it. Brilliant. Enough to be dangerous. Yes, I know that feeling, Kendra. So when we start looking here, this is the background of a Power BI model, practice model. And you can see in here, in this particular report, we have a dimension, we have a category, our categorical data. So within our categorical data, if we look, this is text, you can see it's text, but what you can do is you can transform our text into lowercase, uppercase, you can capitalize it, trim it, so take the spaces off, you can trim the ends, you can do all sorts of things to text data. Whereas if we look at our sales, and our sales here, for example, we've got our indexes, let's go on to price. So if we look at our price, this is a number. So if I look, right click and click on my transform, you'll see I've got lots of different things to my number. I can round it up. So transform, I can round it, I can create absolute values, I can do different things to numbers than I can do with text. So you can even create a new column where you might multiply two things together or divide them together. So Power BI is really, really clever in the same Power in Excel, Power Pivot. It allows you to model and understand your data and make transformations to get it into this really nice, tidy data set. So if we look at our dates, when you have a date here, so this is our date column, when you click on the date, you can actually pull out the year. So I can transform it to find a year. I can pull out the quarter or the week or the day, which enables me to group my Power BI model by different date attributes. Dates are one of the more trickier elements that can be entered in all sorts of ways. So if you've got data that you're pulling in that isn't coming from a nice clean database, you'll find people can write all sorts of things for January. It could be Jan, it can be the date quantity, the date nicely formatted like this. But if you have issues with data generally, for me, quite often I find it's date related. One of the really nice things about Power BI is that in the view, you can actually ask it to show the column quality, column distribution and column profile. So at the moment, it's just showing me the top 1,000 rows, but you can actually change it to show the whole data set if you're dealing with dirty data and you want to actually get it into this nice, tidy data set. And you can see in here, it will show you what the minimum value is, what the maximum, and then the average value. So it gives you sort of a descriptive statistics element of each different column that you have within your data set. And then it also tells you how many are valid, you know, that they're the right data category for that particular type, that particular column, if you've got any errors, and if you've got any empty. And it also, you can see here, it tells me there's 1,000 distinct values, of which 1,000 of them are unique. So I know that this is my primary key for this table, in that it enables me to actually, I would be able to filter or group, create relationships. So, and the same with our customers. So that gives us the ability to create and model our data. Any questions so far? Nope.
I'm not seeing any.
Nope, good. So why do we need this? So in the same way that we were talking earlier about having dimensions and categories, what we do within Power BI is we create a relationship between our dimensions, our categorical data, with our fact data. So if we look back at our Power BI report and we close this and then go into our actual Power BI report, you'll see here that we have regions, products, customers and dates. And what this is doing is it's creating a relationship between the regions table and the sales table. So I don't know why it's doing that. I know why. So when I talked before about having our ability to be able to filter, what we're looking to do when we start looking at sales, for example, what we might want to do is we might want to group, and we might want to filter and then aggregate. So we might want to actually say, right, show me all of the currency that or the channel that is distributor or export or Excel, and we can actually filter to show the distributors. We can say, right, okay, show me warehouse code. So because the data is set up in this particular nice tidy data set, then we're able to filter and we're able to group by these particular attributes. So we're filtering. So we're filtering by our categorical table, our dimensions. Then we group. So if you think of our charts, we then have our groups. So we might have our axes along the bottom. And then we create an expression where we can add up, or we can times, or we can divide. But it's because it's in this nice tidy data set, which then allows us to filter, set up our relationship, filter, group, and then carry out an expression. What's also really useful is we can do this to many different fact tables. So if you're working where you have a budget table and you have your sales table, and you might have a marketing table that's come in showing you results of different campaigns, you can use the same categories to actually filter many different fact tables. So we can have our dates, we'd be able to filter, and we'd then be able to compare the budget for perhaps this fiscal year compared to last fiscal year. We'd be able to drill down and compare by month, or we might be able to compare by salesperson or by product area. So this is why, by having this star schema, any fact table that you have that uses the same index for product can be linked here, and your date can be linked. So when you filter by a date at the top, it will automatically filter all of your fact tables underneath. And this is quite a nice way of bringing in data from different sources, making sure it's in the same tidy data frame, making sure the data types are the same, and that then enables you to carry out multi-fact table report gathering. So one of the things that confused me, one of the many, but one of the things that confused me when I started looking at Power BI and how it's all pulled together is I've come from partly Excel and partly database background, and within databases we're talking about normalization, with normalization being at third normal form, where we're breaking down each table into smaller and smaller and smaller tables. So within the date, we wouldn't necessarily have this huge table of date with every date row, or probably would with date actually, but within product categories, we wouldn't have a product table where we'd have the product and the category and the subcategory and the color. Each repeating attribute is pulled out into a separate table. So you end up with lots of joint tables that filter in. So here you had third normal form for each client, you'd have a city, each city would have a state ID, and each state ID would have a city name, which would be another table. Whereas within Power BI, you would have lots of repeating attributes that you group and then you filter on. And within Power BI, we're talking about normalization, but it's first level of normalization. So here, within Sydney, Australia, you would have the territory repeated each time, which is perfect for a tidy data set. But for me, it took quite a long time to make the link when talking about normalization, that in Power BI, we're talking about first order normalization rather than the third, where we break things down. And this makes writing DAX, when you build reports in Power BI, this means that writing DAX much easier, because you're just filtering by certain territories or certain shortcodes, not different tables which then link back. Any questions on that, or okay? So this is an example, for example, of third normalization, where we're just continually branching off into different smaller and smaller and smaller tables. So why, I mean, you can understand why we do this for data analysis. But within Power BI, we have an engine called the VertiPaq engine. And traditional databases look at each row and they pull out the rows, whereas within VertiPaq, it's a column-based database. So it looks at date as a different column, store as a different column, product as a different column. So that's why it's okay. It's almost in the background that it's creating this third normal form in the back end of VertiPaq, which we don't see and don't, you know, it just does it. We don't need to do it for it. So it's called a column store database. So this is in import mode. Within Power BI, you can have direct query, where you query the data source without bringing the data in. Generally, most of the work I do is in import mode, where we actually pull the data into the Power BI report, and it sits in an analysis services database inside Power BI. Once it pulls the data in, it pulls it in and puts it into a column structure, where it encodes and compresses every column to make it as efficient as possible. And it works out the position of each row within the column and then establishes relationships. So it knows where things are in relation to the other columns. Not quite sure how it does that, but very clever, and it's what makes Power BI very, very quick. If you follow certain guidelines, then it computes and compresses any calculated tables and columns. So how does it do this? It does a thing called run length encoding and dictionary encoding. So if we look at our quarter table here, within this quarter table, and this is why when you start looking at Power BI, this element in the background, which when I showed you how many distinct and how many unique values, this is why this is really important, because the more you have a higher level of cardinality or higher types and values, different values, then it's the compression is less. So when you pull in a table which is full of text, you can't compress it because it might be, you know, the text is very, very different. So if, for example, we look at quarter, within quarter, we only have 4 quarters in a year. So that quarter, that value there, creates a dictionary where we can say quarter 1 equals 0, quarter 2 equals 1, quarter 3 equals 2, quarter 4 equals 3. So we create this dictionary where, again, we've now minimized from having 2 digits down to 1. And if you can think, if it was written quarter as instead of a Q, again, that would decrease the amount that we needed, you know, even further. Because we've only got 4 values used, we only need 2 bits of data for that particular column. And then we use run length encoding. So we then say, right, okay, we've got these values, how many do I need? And then it will go through and say, right, for the first so many rows, I need 310 of this. For this many rows, 290, but you can see there. So one column of data is compressed into, in this example, 1, 2, 3, 4 rows with 4 values. And I don't quite know how it decides which column to compress first, but there is a very clever algorithm in the background that works out which is the most effective method to compress the data to enable it to work quicker. Hopefully I've explained that okay. If you are interested in more, there's lots of research all about, or lots of research, lots of YouTube videos, etc., which explains how the data is compressed in the background. So why do you need to put the data within this particular type? Basically, because it makes it very, very quick. You can bring the data in, you make sure you can compare, you can change it, transform it so that it's set up in this particular type of method. Then you can filter it, then you can group it, and then you can create an expression. And what that enables you to do is it enables you to have a better performance. So by having a star schema, if we go back to our star schema, if we are looking at perhaps the dates for a particular sales, we straight away we're filtering it, so reducing the amount of columns that we need to iterate over to give us the total. So we filter it, we group it, and then we create our expression. So have a star schema. Your star schema enables you to actually have your data structured in such a set way. Only bring in what you need. So if you've got a database full of millions of rows, do you actually need all of those rows? What do you need for this particular report, for this particular, the questions that you need? So, and what columns? What columns do you need to bring in? Only bring in those columns that you need. Lots of text is very, very heavy in the actual memory storage. Any transformations that you want to make to your data, the further upstream you do that, the better. So if you have a SQL database or a CRM system, it's much better if someone's made a spelling mistake or you've got 3 different versions of spelling of product for one particular product. It's better that you actually make those transformations in the model that is feeding your Power BI reports, because otherwise every time you do a Power BI report, you're going to have to make that change downstream. So if you've got any changes to be made to clean up your data, push it up as far up the stream as you can, and that way it's clean for when you pull it in. Be very efficient with your data types and your columns. So an example of that is quite often you will pull in a date time column. If you think about the cardinality, so the uniqueness, a date, we can have 365 days in a year. So that means that we can compress our date by each date. So each sales we could pull in and we can say, right, show me the sales for the 6th of October. And we would just see the 6th of October. Now, if you have time with date, it's like a cross join. The number of permutations of date and time significantly increases. Whereas if you have a column with date and a column with time, then you can actually say, right, show me for this date, you're filtering by that date, show me for that time, and you're filtering by that time. And the engine behind Power BI can then compress and work out the actual optimum structure for creating your model. Optimize your DAX. So anyone that's used Power BI, has anyone used DAX at all? I've tried to use DAX. Yeah, a lot. Yeah, I do. I really enjoyed DAX. But I enjoyed DAX more once I had a efficient model. So by using DAX, you want to make sure you've got a really nice star schema, because DAX works by calculating something and then filtering and grouping. So have your star schema set up, and then it will make your DAX a lot easier. When you talk about optimizing your DAX, it's thinking about how you ask your DAX to do things. So there's huge courses on how you do this, but basically, if you're writing really complex DAX for fairly simple measures, then look at your data model. Most people go straight into DAX and don't think about the Power Query element, which is the bit that allows you to transform and model your data. My advice would be, you need to be good at both, but your DAX will stop you rocking in a dark corner if your Power Query has cleaned up your data. Anything where you're having to clean data or create columns or change tables, do it in Power Query. When you start wanting to group and think about this year compared to last year, this person compared to last person, this measure compared to last measure, that's what your DAX is for. Your DAX is for your business intelligence. So when you start writing DAX, apply your filters on your columns, not necessarily on your tables, because that again makes your DAX more visage. Yeah, rocking in a dark corner. It is. I did do that, Gina, when I first started using DAX. I remember rocking in the corner and thinking, I just don't understand. And then I understood about normalization, and I was like, I get it now. And generally, the last bit is stop when it's good enough. The actual Power BI engine is really good, and you can optimize and optimize and optimize. But when you get to a point where your performance is excellent and is good, then stop, because it will do a lot of it for you. So coming towards the end of the session, so we've got 10 minutes for questions, if you've got any questions, or just chat. Learning outcomes. What I hope I've been able to cover for today's session is that we've talked and discussed, and that you recognise that there are key concepts, basic concepts between different types of data. So we have our numeric, our facts, we have our categorical, which leaves huge ability to create stories with our data that makes them come alive and show us insights. And then we have our time series, which shows us ability to look at forecasting and performance. Data types. Understand what a data type is and what you can do with it. So I showed you some of the user interface options within Power BI and Power Query to transform. There's many more that you can do with different data types, from replacing subsets of strings to creating all sorts of different calculations with numbers, some really interesting date transformations as well. But you can only do that if your column is tidy and each column has a specific data type. Learn how to effectively model data. The star schema is critical. If you're going to build models that have facts, more than one fact table in particular, you need to have a really good star schema, and you need to model your data in that way, so that you have your dimension tables. I always like to put them at the top, because it shows that it's flowing down. I'm flowing down from my dimension table, which is showing me that I want to filter my fact table by my different dimensions. And quite often what I do is I want to check my measures. So I'll filter the tables to make sure that they're correct. And sometimes it just helps understand what I'm trying to do. Understand what is meant by normalized data. So with that, I mean, we have a tidy data set within Power BI, and whether you program in R or you Python, SQL, most of the databases, they're all nice, tidy data set. Each column for a certain variable, for a certain thing, each row is an observation, and each cell has one value only in it. And that is the fundamental for a nice, tidy data set. Importance of a star schema we've covered, and we talked a little bit about how the Vertipack engine works. There are some really good YouTube sessions out there. Kerbal does a really nice one about how the Vertipack engine works, but I think once you start thinking about that it's column based, it compresses each column, and that then helps you understand how to actually, if your model is slow and you've got lots and lots of unique values in there, and so if you think of a descriptive text, do you need to bring that into your model if you're aggregating and grouping? If you don't need to bring it in, don't bring it in. You can always go back and add it later. So that is the end of my whistle-top hour-long session on the importance of data types for optimizing Power BI. I've got about 10 minutes left, I think. So if anyone has any questions or any comments, then I'd be very pleased to hear from them. But I hope you enjoyed the session and that you found it of use. And thank you for joining in.